Here, in this session, we will discuss about how to draw the shear force bending moment. Now, first of all, serial number, load, shear force diagram, bending moment diagram, my dear students. It is a very simple. First of all, here is 1. No load. Suppose here is a cantilever beam. No load variation. But here is load is a W. Only W load is acting. This load doesn't vary. Okay. No load variation. No load variation. Is there any variation of the load? No. So that no load variation. So what is our bending moment? What is that? dm by. So what is that? So suppose here is force, no load variation. So load variation, no load variation, that is df by dx is nothing but 0. Okay. So here is no load variation. Is there any load variation? No load variation. So that from this df is equals to 0. We are integrating that one so that f is equals to constant. Okay. Now the shear force diagram is constant here. Shear force diagram, no load variation. The shear force diagram is like this. It is a rectangle. Okay. Is it clear or not? So here is no load variation. Shear force is constant. Suppose here is a force. Here is force. Sorry. Here is force. Same force. So that force, shear force is constant. Whatever the force is here, same force along the length. So that this variation is x power 0. X power 0. Now, suppose if it is x power 0, now bending moment diagram is x power 1. For this, 1 power is now RC. Y is equals to mx plus c. For this power 1, that is nothing but linear curve. So here is x power 0. One power is more for the bending moment diagram. That is, here is x power 1. X power 1 is nothing but linear. When bending moment diagram is constant, the shear force diagram is constant, that is x power 0. This is rectangular variation. It is also called as rectangular variation. Rectangular variation. Rectangular variation, it is linear variation. Linear variation. Bending moment diagram is linear variation. Okay. When shear force is x power 1, x power 0, bending moment is 1 degree more than shear force. That is bending moment diagram. So next coming to, so here is the, when load is constant, when load is constant, that is df by dx is equals to constant. It is equals to constant. So that df is equals to c into dx. We are integrating that one. F is equals to c into x plus c1. It is in a form of y is equal to mx plus c. Now this shear force diagram is linear. Shear force diagram is linear. For linear, what is this power? X power 1. Suppose 1 degree. What is bending moment diagram? 1 degree more than shear force diagram. That is bending moment diagram. For this 1 degree more. So that now that is x power 2. X power 2 is nothing but y is equals to ax square plus bx plus c. This is second degree parabola. Now this is second degree parabola. Now this is x power 2 variation. This is second degree parabola. Second degree parabola, my dear students. Yes. Now coming to third one. So if load varies linearly, this is a linear variation. This is a linear variation. That is, it is in a form of, this is x power 0. So it is a rectangular variation. For rectangular variation, x power 0. This is x power 1. 1 degree more for this, 1 degree more for bending moment diagram. Similar fashion. What is this? X power 1, it is a linear. 1 degree more for this. So here is for shear force diagram, 1 degree more than load diagram. Suppose now this is second degree parabola. This is x power 2 variation. Now it is x power 3 variation. This is x power 3 variation. This is when load is linear variation. At that time, the shear force diagram is second degree parabola variation. Bending moment diagram is third degree parabola variation. That is, bending moment is 1 degree more than the shear force. Shear force is 1 degree more than the load. All of you clear? It is a very, very important, my dear students. So, at the time of solving the problems, it is a very, very important.